Great. So, first question. Define the phase controlled rectifier. So, what is a rectifier? A rectifier converts AC to DC. That's a rectifier. Now, there is a word here, phase controlled. What is a phase? According to mathematics, a phase is an angle, right? That's a phase. So, when we say define a phase controlled rectifier, we are simply saying we want this conversion to be controlled. So what is the answer? The answer is like this. A phase controlled rectifier is a of rectifier circuit where the angle is controlled to just the DC output voltage or current. That's my answer. A phase controlled rectifier is a type of rectifier circuit where the bearing angle is controlled to determine or adjust the DC output voltage or controller. Okay.
Or current.
Yes, I mean or current. Yeah.
Current.
Okay.
Is that okay?
Yes, sir.
Good. Part B. Fabi, welcome. Afternoon.
Thank you, sir.
Okay. I'm fine. I'm well. Yeah. Part B.
Okay. Question B says, state two applications of controlled rectifiers.
Two applications. And it's very simple. It's saying state. Two applications. Okay? State. Not text. Just list. So where do we use the controlled rectifiers?
We use them on variable DC output.
Where else?
High voltage DC transmission. Maybe battery charging with controlled current.
You can just say speed control of DC motors.
Yes.
Don't just say motors, say DC motors, because power electronics can only control DC motors, not AC motors. So this is very important.
Yes, sir.
DC motors. Also,
Sir, Mr. Daka, Mr. Kundwa.
Yes,
Mr.
Yes,
Gonga.
Mr. Joshua.
I'm lagging behind. Which paper? What are we looking into?
was talking about
It's
Like
20,
power.
20.
it's 2025, April, May series.
2025 April, May period. Okay, question.
Question 1.
Question 1, power electronics.
Okay, yes, I've seen it now. Okay, we are
machines.
together now. Sir?
I hope tamachingira mu machines.
And power electronics. Power electronics.
High power DC supplies. If you want further, you can say used in welding. Welding is one of the examples. Those machines that use the TIG welding, MIG welding, they use rectifiers. Yeah. DC phase controlled rectifiers. Is that okay?
Yes.
We proceed.
Yes, sir.
Power, can we proceed?
No, I'm just noting out the application. Speed controller of the DC, and
Good.
they are used in power. Okay.
Yes.
Okay.
Good. See? What's the question saying?
Explain the function of freewheeling diodes in controlled rectifier.
Freewheeling diode. Function of freewheeling diode in control D rectifiers. Okay. So, in order to answer such a question, when they say explain, you need to talk about the three things. Okay. In order for you to answer such a question to get the full marks, you need to talk about the three things. Okay. What are the three things? Number one, talk about the connection, how it is connected. Number two, talk about the why needed. Okay. Or before you say why, maybe let me say how. The connection, how, and then why, which is the function. So maybe I put it like this. Where, which is the connection. How, we are talking about the principle of operation. Why, the function. So even whether it's the machines, power electronics, control, system control, when they ask a function about something, in your description, in your explanation, include the where, how, and why. Then you would have answered the question correctly. Okay. So, having said that, can we now answer the question why a freewheeling diode is explain? Can you now explain the function of a freewheeling diode in control D rectifiers? So I'll start like this. a freewheeling diode is connected in parallel. Okay? In parallel across the load. So we have answered the first part, where it is connected. So freewheeling diode is connected in parallel across the load.
Okay.
Okay? When SCRs, what are SCRs? Silicon controlled rectifiers. Feed an induction load. Okay? It keeps flowing. Do we all remember what an inductor is? An inductor stores energy in terms of what? Current. A capacitor stores energy in terms of what? Voltage. So, capacitor is to voltage as inductor is to current.
Current.
So a freewheeling diode is connected across the road. Why? Because when a silicon controlled rectifier feeds an inductive load, current keeps flowing when he turned off. Okay. So when we turn
Yes, sir.
off, because the inductor stored some energy, that current will keep on what? Flowing. Okay. So two things have been mentioned here, where it is connected and the principle. Okay. So we go to the last thing. Okay. So freewheeling diode provides the alternative path for current from inductive load to flow. Without producing a high reverse voltage.
What the?
Yeah. So three things. Number one, where it is connected. Where is it connected? In the parallel. Okay. Number two, it keeps the flowing when it turns off. Why? To prevent the higher reverse voltage. So all we are avoiding here, remember this is a rectifier. A rectifier means what? Current should be flowing in one direction. Only in one direction. That's a rectifier. Okay. So we provide the freewheeling diode in order to ensure that even when it is switched off, there is no reverse voltage. Understood?
Understood, sir.
Excellent. We proceed. Okay. Yes. What is part D saying?
Part D says state 4 advantages of freewheeling diodes in a controlled rectifier.
4 advantages. Okay. Number 1. Protects SCRs from voltage spikes. Number 2, lower switching and conduction losses. Number 3, control of power by changing firing angle. Number 4, reliability without moving in parts. High reliability without moving in parts. Okay. Is it happening? Oh, some people have been kicked out by network. Let's hope they'll find us. Hello, Fabi.
Yes, sir. I'm here.
Okay,
Following.
great. Can we proceed?
Yes.
Okay. This was part D. Part E. This question was very long. Who says such a question? Trying to avoid the people to become technologists. But we are not focusing on promotion. Eh?
But E,
Yes.
state 4 advantages of SCRs.
SCRs, 4 advantages.
Yes.
Okay. Number 1. Ability to handle high voltage. Yeah. Number 3.
Number 2.
Ah, we have made the mistake. I think the answers for part F mean part D. Sorry. Let's go back to D. 4 advantages of freewheeling diode. Sorry. Number 1, we said what? Protection of
SCRs.
SCRs. Good. Number 2 is improves voltage output. Okay? Improves voltage output, not what you have written. Then number 3 reduces form ratio. Reduces form ratio close to RMS, root mean square. We know this. Then lastly, increase the efficiency. Okay. Those are the 4. So the other 3 I'd given you, I was giving you answers for part D. I mean for part E. Yeah. So let's go back now to E. Okay. We now go to E, which is also asking for 4 things, which are now 4 advantages of ACRs. I mean SCRs. Good. Number 1, ability to handle high voltage. Number 2, low switching and conduction losses. Okay. Low switching and conduction losses. Mr. Kondwan, welcome back. We are sure the network had booted you out. Okay. The number 3, ability to control the firing angle. Okay. And finally, higher reliability because there's no moving parts. Higher reliability because there's no moving parts. Okay. Oof. Great.
Sorry, I was off for a while. I had network problems, but I'm back. I'm back online now.
Oh, yeah. We observed. Anyway, we have continued. You will be able to follow up the video, but I'll also send the answers. Yeah.
Okay, yeah.
Great. Especially to those that have paid. Yeah.
Okay, yeah. Sure.
It's the reason we left the village before money in town. Yeah.
Uh,
Okay. Part F.
Okay, part F says a single phase 230 volts, 50 Hz, one pulse SCR controlled converter is triggered at the firing angle of 35 degrees and the load current extinguishes at an angle of 220 degrees. Find the circuit turn-off time, average output voltage, and the average load current for 1 R equals 7 ohms and L equals 2 millihenries, 2 R equals 58 ohms, L equals 4 millihenries, and E equals 110 volts.
Okay. So we are finding what? The turn-off time.
Exactly, sir.
The turn-off time. Correct. Great. So what's the formula for the turn-off time?
Change of time.
Yes. What's the formula? Okay. F. Great. Here, I'll take my time because there are a lot of things that I'm sure are not part of your head. Yeah. So single phase SCR converter calculations. Okay. So first things, turn off time. Okay. T off. What is the formula? Yes, what's the formula for T off? Beta minus alpha over omega. Yeah. That's the formula. Beta minus alpha over omega. We are putting it in red to show the seriousness of the matter. Even the Bible I have, there are some words which are in red, which were said by Jesus himself. So there you put ugly.
Yeah.
I don't know which Bible you read. You know, in the Bible, there are things spoken by people. Even the donkey also spoke in the Bible, even the snake. But when you see in red, it is Jesus himself. Yeah. Which means it is not a suggestion. We can't argue. It was already agreed.
Yes.
What is the beta? So let's start with alpha. Alpha is the firing angle. Okay. Beta is the extinction angle. Okay. The omega is the, what is omega? It's the speed 2 pi f in rad per second. That is what you need to get. Okay. So beta minus alpha over omega. Yeah. And this is why I like the diploma in engineering. Because now we stop using alphabetical order in English. We start using Greek alphabetical order. You have seen the letters which are there.
Yes,
Yeah.
yes,
So
yes.
that if your spouse has not done engineering, when she comes to your desk right now, just write it down. Then she will know that he or she will know that this is another level. Yeah. This is where we
indeed.
differ with. This is where the difference comes in with lawyers. This is where the difference comes in with accountants, because them formulas they are using English alphabet, as we're using the Greek alphabet. This is when this is when I feel I'm a DDK. Yeah. Great.
Yeah.
So that is the time of time. What about the average output? What's the formula? So we are just discussing the formula, then we'll solve later. Okay.
Yes, yes.
There's also average output voltage. Okay. Average output voltage. For me, even if we solve one question or two questions, but what is important is time for me to explain these things. So that even if the question comes in a different format, you should still be able to get it. Okay?
For sure.
Yes, sir.
Good.
Sure,
So,
sir.
we are not interested in quality, in quantity, but quality. Yeah. V average is equal to